Now we are going to learn the quotient rule. So we learned the product rule last. That's the last thing we learned on Friday. Today we're going to learn the quotient rule. And this is it. So go ahead and copy it down and I'll explain it to you. Alright, so here's how this one works. So you got something divided by something else, so the quotient of something. It's going to be the bottom thing times the derivative of the top thing. Okay, the bottom thing times the derivative of the top thing minus the top thing times the derivative of the bottom thing all over the bottom thing squared. So I'll say that again. Bottom thing times the derivative of the top thing minus the top thing divided by, times the derivative of the bottom thing, all divided by the bottom thing squared. So let's say we have those two, and yes, you can simplify it in this example, but you will come to examples where you won't be able to simplify it. So we're going to use this as an example while it's still simple. So we got the bottom thing times the derivative of the top thing. So x cubed times, what's the derivative of the top thing? 2x. 2x, so x cubed times 2x minus the top thing, so x squared, times the derivative of the bottom thing, which is 3x squared, all over the bottom thing squared, so x to the power of 6. So again, the bottom thing times the derivative of the top thing minus the top thing times the derivative of the bottom thing all over the bottom thing squared. Yes. Okay, any questions there? Okay, now you would simplify it. So we get 2x cubed minus 3x cubed, to the fourth, over x to the sixth.
Oh,
yeah.
Cubed.
Yeah, I know, I fixed it. That's to the fourth after that. You got my $10? Give me my $10 for punching in your mouth. And then you would simplify that. There you go.
Wait, no.
I'll give you my $10.
Give me my $10. I'll track you down, break you on.
Alright. You gotta turn on camera.
Sorry, I just cut it out. Alright, any questions with this? Okay, so this is the way you want to memorize this, or this is the way you can memorize this if you don't memorize this formula, because it is a little more complicated. It's not as simple as the product rule. So there's a saying, low d high minus high d low all over low squared. So what it is low d high, so d stands for derivative, low times the derivative of the thing that's on top, so high, so low d high, minus high d low, so high times the derivative of the bottom thing, all over low squared.
Can you say that again?
Yeah. Low d high minus high d low all over low squared.
Can't you just do like maybe how
one, yeah. This one, yeah. Not the next one. What happens if you have x squared plus 1 over x cubed minus 5? I mean, yeah, you could change it to the product rule, I guess.
I'll see the problem.
Okay. So low D high minus high D low all over low squared is one way people memorize it. This is how I memorize it. Alright, any questions with that? Okay. So for example, we have this. This you can't just simplify like the last problem. But you gotta take the derivative. So you can do the quotient rule. Are you saying, Jackie, are you saying you change the x squared plus 1 so it has a power of negative 1?
Yeah.
And you do the product rule?
Yeah.
You can do that. Practice quotient rule though. But yeah, you can't do that. Alright, so Jackie brought up the question of, can't you just do the x squared plus 1 to the power of negative 1? So that's two parentheses next to each other and then do the product rule? Yes, except you have to know the chain rule, which you don't know yet, but apparently Jackie does. So then the answer actually would be no right now, because you guys don't know enough yet. So you have to do the quotient rule here. Alright, so you're going to set it up. So go ahead and try to set up the problem. Low D high minus high D low all over low squared. Go ahead and see if you can set it up correctly. Alright, so you should have this. You should have x squared plus 1 in parentheses times 2x minus x squared minus 1 in parentheses times 2x all over x squared plus 1 squared. Any questions there?
Wow.
Anyone not sure where I got that from? Okay, you just took the derivative. You just did the calculus part. Now comes the algebra. The most common mistake that people will make here is with what? What do you think? With the negative. When you distribute the 2x, you distribute it to both of these, but you still got to keep that inside the parentheses until you distribute the negative also. Go ahead and simplify this. So just multiply. No, not everything. If everything cancels out, you mess up on the negative. Yeah. Which one? This one or this one? Okay, so low, right, so that's this, times the derivative of top. So low D high, so the derivative of x squared minus 1 is 2x. Alright, so you should have this. And then you distribute your negative. And then you can cancel out. No, you don't need to do all that stuff. And yes, you can't leave the bottom one. And yeah, I can read lines. Yeah.
So you don't want us to factor out the bottom, right?
Nope. You can leave it like that.
If you look at the squares over it's the fourth.
What? Say what?
If you factor the square.
Factor out what square?
Like, oh!
Talking about the denominator?
Yeah.
Did you just say x to the fourth plus 1?
Yeah. Messed up.
Then you definitely get points taken off. Yeah. No. Yes. First of all, you can't factor anything out from the bottom. Multiply?
Yeah.
No. don't multiply it. Yeah.
What if we do? Will you mark us off?
No. If you actually multiply it, I would not take points off unless you multiplied it wrong. So don't multiply it. Especially don't write x to the 4th plus 1. Alright, any questions here?
No.
Anyone still copying down? Alright, try this. Yourself. Once you're done, you're going to wait for the person next to you to be done, and then you're going to check your answer with them. But don't bother them if they're still working on it. You got 9 people around you. I'm sure someone else will be done, the person directly to your right or left or not. So, yes, in the last example, I did say you don't need to multiply it out. But that's because multiplying it out doesn't simplify it anymore. It doesn't do anything, just multiplying for the sake of multiplying. Here, in this problem, you actually would simplify the bottom. You actually would multiply them out because you can simplify it somewhat.
I haven't seen it. I'll be eternally grateful. I'm really mad. Really? Yeah. You take away the whole, there's some the whole sum. The word whole sum.
Alright, good.
What's that mean?
Oh, yeah.
This is the word. Whole sum, right? You take away whole, you get
So let me explain this real quick. We got low d high, so low times the derivative of the thing on top minus high d low. So this in parentheses, I saw some of you guys didn't keep this in parentheses. Make sure you keep this in parentheses times the derivative of low, which is just 2, all over low squared, so 2 squared here. You distribute the stuff, you multiply it out, you get this. This you do want to square it because you actually can simplify everything by 2 here. So you simplify everything by 2. The only thing I'm going to ask you to do that Aaron did not do is something like this. Because you're not just simplifying from here to here. But it's a completely different equation. Now if it said simplify and then you just wrote equal, that's okay. Because it's equal to the original equation. But here, these two are not equal. It's completely different. So you can't just write the expression. You can't just write equals. You got to at least have this somewhere. Now if you have it up here and then your answer said equal, that's okay. If you don't have it up here, your answer needs to have it then. Because if you don't, then this is assuming this is equal to this, which is not. Yeah?
You mark things off when you don't have it?
I probably won't, but this is something you want to be conscious about. Because let's say you didn't have these two things on there. You're saying this is equal to this, and you just simplified it, and it's not. Maybe I will take points off, I don't know. Sure, I'll take points off.
Be generous.
Great.
With the people
You don't have to. You don't have to.
Just know that, you want to make sure you have this somewhere. Alright. Any questions?
Not.
Here's the example 4. Find an equation of the line tangent to the curve. So this curve right here at point 1, 2. Find an equation for the line tangent to the curve of that function at point 1, 2. Now what do you notice about the function of this curve? Okay, it does have an x and y. What else? What else do you notice about it?
Same one as before.
The same one as the previous example.
But we have to square it on the bottom.
There's no square on the bottom.
Oh, okay.
Alright, now if we're going to look for an equation for the line tangent to this curve, we need to know one thing first. What do we need to know first? The slope. We need to figure out the slope first. Now in order to figure out the slope, we need to take what? We need to take the derivative. But we already took the derivative. Okay, the derivative was your practice problem. And that's that. And I just simplified it a little bit more. Any questions as to how I got this part? Wait. So your original, what was your answer for the derivative earlier?
X squared minus 3 over x squared.
So I split it up. And x squared cancels out here, so you have 1 over 2 is equal to negative 3 over, or minus 2x squared.
Where did the square go?
Oh, okay, so the square should be there then, right?
What?
Okay, so let's do this.
Why are you doing that for again?
Because we're looking for the slope. And in order to find the slope, you need to find the derivative first. Because what is the derivative? Slope. Right, so we're looking for the slope, you got to take the derivative. Okay, so here's your derivative. Any questions there?
Can't just plug into X or that.
Can you plug into the x in here?
Yeah, but wait.
Then it's going to give you 2. Okay, so this is our slope of the curve. Now we're going to find the slope at this point. So now we plug 1 into x. We have 1/2 minus 3 over 2 times 1 squared. Okay, so it actually comes out to be the same. So we can do this. And that equals negative 1.
Yeah, you can just you don't really have to do that. You can just put it in the first where you had like the last. Yeah. You didn't have to do that.
Do what?
You could just plug in one for the.
You mean up here?
Yeah.
I know.
Oh.
But I asked if you guys knew how to get this, and a lot of people said no.
Oh.
So that's what I was explaining.
Why?
So that,
Are you gonna have to do
want
that?
to test?
No.
No,
What?
but why would
that's what you would want on a test.
I don't know, because I just happened to split it up.
Oh, okay.
Okay, so this is the question. This is what you guys left it as in your answer in the last problem. This is how I set it up in my PowerPoint. So the question was, how did I get from here to here? This is how I got from here to here. Do you have to do this? No, because these two are equal. I'm just answering the question of how I got this. Alright, so you plug in 1 into x, and this should be a squared, but it doesn't change the value. Alright, what's negative 1? Slope. Okay, so that's the slope. So now what do we do? Plug into what? Y equals mx plus b. If you ever need to write an equation, you want to start with y equals mx plus b. If you haven't noticed yet, we've been doing these types of problems in basically every section, this chapter and some of the last chapter. You're going to need to know how to do this. Alright, so we know our slope. What's our slope? Negative 1. So we plug that in there. What else do we know about this?
The y and the x.
We know the x and the y. So we plug those numbers in there also. So what are we looking for? The b, the y-intercepts. So you solve for b. B is equal to 3. Any questions so far? Alright, so go ahead and write your equation. Okay, so you should have got that. Any questions there? Anyone see comments down? Okay. Alright, so we can also take the derivative more than once. And we kind of talked about this on Friday. So there's something called first derivative, second derivative, third derivative, fourth derivative, and so on. But it actually gets easier each time. Or usually gets easier each time. So we're going to find the first 4 derivatives of this function here. This is your equation. Y equals x cubed minus 5x squared plus 2. Okay, so we take the derivative of that. Go and take the derivative of that equation.
On the one before, the slope is negative 1, right? But that's only assuming like they plug in the point 1 inside. Right?
That's the slope is so the slope is negative 1 only at that point.
Yeah, so the equation won't be y with negative x, will it?
No, not for the entire graph.
Yeah, so
So the equation of the tangent line to that point is that equation. Alright, so someone volunteer and give me the first derivative of that equation. Ricky.
Y equals 3x squared minus x.
Say that again?
Y equals 3x squared minus 10x.
Almost, except it's not y equals that.
Y prime equals...
Y prime. Y prime. Okay. So y prime equals 3x squared minus 10x. Any questions there? Yep. So this is y prime, y double prime, y triple prime, y quadruple prime. Go ahead and find the other 3.
So basically you just do that 4 times.
Yep. You do 4 times.
What?
Alright.
Go to the meet.
Anyone still working on this? Geneva, give me the next one.
6x minus 10.
Geneva, give me the next one.
Six.
What?
Now we add that.
Okay. Devin, give me the last one.
0.
Good. Any questions? If I'm calling one person, that's the only person's voice I want to hear. Yeah.
Where is the x? 10x to the x? What happened?
What happened to this right here?
Yeah.
So the power is 1, right? And then you bring the 1 down, so 1 times 10 is 10. And then it becomes x to the power of 0. Any questions? Alright, there's your assignment.